All right, welcome to this explainer. If you're building software, you already know that data is basically the lifeblood of your entire architecture. But there is a really massive difference between just storing that data and actually talking to your database effectively. You see, the query languages we choose, they don't just dictate the syntax we type. They are quite literally the difference between a lightning-fast app and a 3 a.m. PagerDuty alert. So today, we're going to explore how we evolved from micromanaging our data access to letting the system do the heavy lifting for us.
To really anchor this in reality, let's start with a practical, everyday engineering challenge. Picture this. You're building the back end for a massive e-commerce platform. Your product manager comes up to you with a seemingly simple request. They say, "Hey, we need to send a promotional email. Can you just find all active users in New York who placed an order in the last 30 days? Sounds super easy, right? Your brain probably immediately starts thinking about users, cities, account statuses, and order dates. Well, let's look at how we might be tempted to solve this using standard application code.
You might immediately think of using imperative pseudocode. Notice how natural this feels at first glance. We're writing a simple set of instructions. We essentially tell the system, okay, loop through every single user in the database. For each one, we check if they live in New York and if their account is active. If they pass that test, we make another call to fetch their orders, filter those by date, and finally add them to our result list. We are explicitly giving the computer a step-by-step recipe for exactly how to achieve our goal.
But here's the catch, and it's a big one. The fragility of imperative access becomes obvious at scale. Think of it like being a micromanager in a massive commercial kitchen. Instead of just ordering a cake from the chef, you're walking them to the fridge, telling them to pick up an egg, check if it's cracked, put it in a bowl, and then go all the way back for the next egg. It's exhausting. By writing application logic this way with too much application logic dictating the flow, we force the system into inefficient data scanning. It has to look through potentially millions of users. And it's so much harder to optimize. Every time you change the ordering of your data or add a new index, your application code might just break. Plus, it leaves increased room for bugs. You're basically doing the database's job for it, and frankly, you probably aren't doing it as well.
This brings us to the absolute magic weapon of data engineering, declarative querying. Instead of giving the database a step-by-step imperative recipe, you simply describe the pattern of the data you want. You state the conditions the results must meet, the what, and you completely ignore the how. It's describing what results you want from the system rather than telling the system how to scan and filter for it. It is a total paradigm shift in the developer experience, handing off all those tedious implementation details to the database engine itself.
And solving our e-commerce problem with declarative SQL is just a brilliant exercise in clean intent. We just ask the system to select the user's ID, name, and order count. We tell it to join the users and orders tables. We lay out our where conditions, New York, active status, last 30 days. And finally, we group and sort it. That's it. Nowhere are we writing a for loop, and nowhere are we dictating which table to read first. We just describe the end goal.
When we compare imperative for loops and manual filters directly against declarative SQL select and join statements, the contrast really helps build your architectural strategy. The imperative manual filters are bulky, they're rigid, and if our data grows to 1 billion rows, that loop is absolutely going to choke. But the declarative SQL simply states the requirements. This separation of concerns frees you from writing complex manual access paths. But it does beg a pretty important question. If we aren't telling the system how to fetch the data, who exactly is?
Well, the answer is the database's query optimizer. Because SQL is declarative, the database has the freedom to be incredibly smart behind the scenes. This is the optimizer's magic. It literally looks at your query and says, okay, I have an index on the city column, so I'll use that to filter out non-New York users before I even touch the orders table. It automatically chooses the most efficient join order, it filters early, and it aggregates efficiently. These optimizers are the result of decades of intense computer science research. And by using a declarative language, your application gets to benefit from all those PhDs for free.
Expanding the universe. Document queries.
Now, relational tables are super powerful, but our e-commerce platform isn't just dealing with nicely structured users anymore. We have to handle diverse product catalogs. Think about it, a laptop has RAM specs, right? But a t-shirt has size and color. Forcing that into rigid tables is a total nightmare. This is where we encounter schema on read. In traditional databases, the system enforces a strict structure on write, but with schema on read, the data structure is implicit and only interpreted by the application when the data is read, not enforced on write.
You store flexible JSON-like documents, and the app figures it out later. It's absolute perfection for diverse catalogs where every single item might be a little bit unique.
To query this kind of JSON-like data, we use document query languages. For instance, you might use a db.users.find command, passing in criteria like city, status, and last login dates. It still operates on a declarative principle, but it uses a JSON-based syntax to match patterns. And what's really fantastic about the document model is the locality. Because a user's entire profile or a product's details are stored as a single contiguous document, the database can fetch all that relevant info in a single go. You completely sidestep the need for messy joins across dozens of tables.
Navigating interconnected graph data. But what happens when the relationships between your data points are actually the most important part of your data? Imagine building a recommendation engine to show products bought by friends of my friends. In a standard relational database, that is a nightmare of deeply nested joins. When your data is this interconnected, you really need to model it as a graph. You have vertices and edges representing complex interconnected relationships. Vertices are things like users or products, and edges are the relationships, like knows or purchased. There's no rigid schema. It naturally maps out a web of social connections exactly as they exist in the real world.
And to navigate this web, we use graph query languages. A higher-level graph query lets you express things like find friends of friends who like the same product. Whether it's Cypher or Sparkle, these declarative languages are purpose-built for this. Instead of a bunch of table joins, you essentially draw an ASCII art arrow in your query to say, follow this path from user A through their friends to user B and find the product they liked. It lets you express highly complex many-to-many traversals concisely and easily, while the database engine figures out the most efficient way to walk those paths.
Let's bring this all together. What we've really seen today is the power of intent. A query language is far more than just syntax on a screen. It shapes developer experience by acting as the critical interface where your intent meets system execution. It dictates system performance by allowing the database optimizer to take over the heavy lifting. And crucially, it allows databases to evolve their execution plans entirely safely without ever breaking our application code.
As we wrap up this explainer, I really want to leave you with a thought. We've seen how liberating it is to hand over the how to the database and just focus on the what. It fundamentally changes how we design systems from the ground up. So take a look at your own application architecture today. Are you fully leveraging the power of declarative intent, or are you still manually writing those access paths? If a good query language figures out how to fetch your data, what other engineering problems are you still micromanaging? Think about it. Thanks for joining me on this deep dive into data access, and keep building smarter systems.